Thanks, Mike. Thanks, everyone, for attending today. Jamie, thanks for the great framework that you developed for what basically the product and discussion that I'm going to have today. If I can boil it down into two words having to do with after-treatment systems as it pertains to stage 5, it's smaller and performs better. So that's the goal of what we were after, and I'm going to talk through a little bit more background in terms of what the process that we used to try to determine what the proper solution was for stage 5. And we have a couple of different solutions. One of them is remarkably similar to the single module one that Cummins just showed. So I want to walk way back, 100 years ago, a little more so. Donaldson started in 1915. A guy named Frank Donaldson was an engineer working for the Bull Tractor Company. He was out in the field, saw farmers were having all sorts of engine failures over and over again, said, I know how to solve it. He created an air filter, problem goes away. Company said, you just destroyed all of our engine sales, you're fired. He starts a company. Today we're sitting at about $2.2 billion worth of sales. We're located around the world with more than 12,000 employees. Our primary business is filtration. Down in the right-hand side, primary for the engines, but we make filters all the way from hearing aids all the way to the large filters that you would find in a manufacturing facility. We also do liquid and hydraulic filters, and what I'm going to talk about today is both exhaust and after-treatment products that we offer. So we've been in the after-treatment business since 1990. We started primarily in the retrofit side, producing DOCs, not only for the on-road market, but we also provided OEM product for DOCs. We were doing DPFs as well. Our first foray into the SCR market was in 2008 on a stage 3A configuration for an ag tractor. From there, we've basically looked at how do you compact more and more of the package into a smaller volume and get more out of it. So the next version that we show here, and it's a little hard to see if those of you in the back, but there's a DOC, a DPF, and a doser and a mixer that's downstream of that, all into one package, which, as we know, on an off-road vehicle is very critical. From there, we moved to a DOC and an SCR system with a mixer in between, again, all integrated into a single package to meet Tier 4 final requirements, and there was a discussion about that today, about meeting stage 4 without a DPF. So where do we go from there? Again, this is a very similar package. You compact everything into a single configuration that can be easily installed into an off-road vehicle. So from an off-road market, I don't have any pictures of the different vehicles, but I think you know them fairly well. The challenge is there's many different types of off-road vehicles. The volume for any one given vehicle and configuration is not very high. So coming up with solutions that can integrate into the vehicle is a challenge, and nobody wants to spend a lot of money to uniquely tool one. So you have to figure out how to make as few number of components fit onto the vehicle as possible. What are some of the key attributes that you're looking for? It needs to be compact. It needs to be modular. It needs to be robust. And it needs to be well integrated. The last thing that we want as an industry is something that looks like it was bolted on like 4 days before you decided to run it down the assembly line. We need to have it integrated into the package. It needs to be modular because not one solution is going to solve every vehicle's problem, but it needs to be as compact as possible. And obviously it needs to be robust. It's on an off-road vehicle. So those were the constraints that we were working within. So I'm going to switch a little bit. Let's talk about SCR systems for a moment, because this is the real key. As we look at SCR systems for stage 5, not only do we have the particulate number, but we have improved efficiency that we're trying to achieve. We know that we're going to be dealing with less and less levels of EGR, and the last thing that anyone wants to deal with is a bunch of deposits on a flapper mixer. So we looked at it and said, okay, what are the things that we're after? We need good distribution, good velocity distribution at the SCR face, and that's regardless of what happens upstream or downstream. We need to have good def mixing, because we know that not only is the market going for 95% uniformity, but 98% uniformity and levels even higher than that. We need to be able to make sure that it can handle heat loss. We know it needs to run on a 9EGR. It needs to be heavy duty. And then that last one is, how do you come up with as few configurations, because nobody wants to have to revalidate every configuration that the engineering team can come up with. So we looked at that challenge and we incorporated what we already knew about mixing. And from a mixing standpoint, we know that turbulence is good in an SCR system. In particular, we use a swirl mixing style. We have that on basically our Tier 3 and Tier 4 solutions that we have in the marketplace today. We start with a bulk mixing. It's a little hard to see down in the bottom, but picture a big swirling flow that breaks into smaller flows, that breaks into smaller flows, and the doser that's spraying down here, as you can see in the CFD model, the doser spraying down the middle. The droplets don't hit the cold wall of the mixer. They stay in suspension until they're completely vaporized, and then they hit the SCR face. So we looked at that and said, okay, but now we need to go even higher levels of dosing to get even better efficiency. So I'm going to walk you back to the beginning of the program. We talked about this a little bit about 2 years ago at this conference and last year at SAE. So we created a little plexiglass window in a tube and put a doser on the side, and we had it spraying onto a flat plate that we had thermocoupled on the bottom. Why? Because we wanted to figure out what is it going to take to model this thing so we can, through CFD, determine what's the best mixing configuration. So I'm going to set this one up and hopefully it'll show. So what you're going to see here, and it'll replay a couple of times, so there's 3 sprays. Plumes 2 and 3, you can see that there's white deposits forming in that location. Plume 1, same temperature, same flow, no deposit. Well, why? Now you have a difference. So we looked at that and we said, okay, if we can model the difference between plume 1, 2, and 3, we've now kind of hit at the heart of where deposit formation begins. We have to manually tweak that one forward so we can go to the next slide. Okay, so if we take a look at this and look at it from a modeling standpoint, and you look at the heat transfer versus temperature graph, and I'm not going to try to explain the Leidenfrost and Nukiyama point and all that, but the bottom line is you've got a droplet that is sitting in the pan boiling, and we said, well, how can we try to simulate that in the test rig that we had? And again, it may be a little hard to see, but we have a slowly decreasing temperature as a function of time. And the thermocouples that are on the bottom here are seeing a decrease depending on whether you're looking at plumes 1, 2, and 3. The deposit formation is occurring when this is coming down. And so what we did is we modeled that. Now, we didn't model 4 hours of this data. For those of you who know CFD, you know that that's not possible. But this is a simulation, and what you're looking at here is where it turns blue is where the doser is spraying on the plate and the temperatures are dropping rapidly. You know that that's where the deposits are going to form. Okay? So we used that knowledge, and then we said, okay, how can we correlate that back to our CFD? So we looked at the CFD, we generated our model, we tweaked about 14, 15, 20 different parameters until we finally had correlation in a very simple model. And then from there, I'm going to condense this down to basically a year and a half into a slide or two, and we came up with basically a mesh that we're spraying on. So we took from that flat plate to a mesh that we were able to spray on and spray without generating deposits despite relatively high flow. If you want more details, the SAE paper that we did last year goes into quite a few of those details. What I want to spend a little bit of time on, though, is what the outcome of that is and kind of how we got there. So the 2 parameters that we're worried about with these new generation of stage 5 mixers are deposits and performance, in addition to size, right? So from a performance standpoint, we looked at it and we started out with a measurement where we measured like maybe 7 points of NOx downstream from the SCR can, and then we increased that to 13. Then we ended up with 32 points of measurement, And this is all integrated into our data acquisition system on the dyno or on the burner. And these are some actual test runs on some engines, different RPMs on this axis, different temperatures on that axis. And we're looking at uniformity. And we're doing that for a given design, and we're repeating that with each different change that we make. So we have a fairly automated, fairly rapid way that we can generate our uniformity characteristics. So the uniformity is fairly straightforward. What about deposits? Run the deposit test, take it apart, look and see if you generated deposits, right? Very long, very slow. So we looked at it and said, what about putting a borescope into the system, and how about if we automate the borescope? So the borescope's taking pictures every 5 seconds or 10 seconds or 15 seconds, and we can make our changes and run it over long periods of time, run it over a weekend, you leave on Friday, you come back on Monday, you have your results. And within here we've got, again, we're running whatever parameters we have on the graph that I show on here that you can't quite see, but you'll see it in the presentation, is we have different RPMs, different temperatures that we're running, and within here, we take those pictures every few seconds. We're looking to see whether the deposit forms, because maybe the deposit isn't there after an hour, but it's there after 3 hours. And then we keep running those points, and as we begin to refine the mixer, we can now push it to higher and higher levels of dosing rate. So these are two of our primary tools, along with CFD, that we use to develop our systems. So what are these systems? Handful of systems based on current swirl technology as well as spray-on mesh technology. And I'm going to walk through a couple of these. So a few of these are box-style systems. A few of them are fully integrated. One of them is a switchback. So a handful of options rather than an infinite number of options depending on what every customer would have. So a box-style system. Common on off-road. Can you apply it to off-road? Of course you can. Basic concept is DOC, DPF. In this case, there's the swirl mixer. We call that our twister. That's our twister technology. The spray is going down the middle of the mixer. It does not spray on the wall, but by the time it reaches the outlet, it should be reasonably uniform, and it can go through one of two parallel SCR systems. Okay? So here you'll see over on the right-hand side some of the swirl characteristics from the CFD. You can easily put this on an excavator, on a combine. And the idea behind it is the only thing that really varies is the inlet and the outlet, how you mount it. So conceivably, you don't have to go through and revalidate this for each and every vehicle, assuming you already know what the vehicle vibrational loads are. So the next system is one that could be used for stage 5, but it's a derivative of a current product that we have in Tier 4 final, and that's a swirl style mixer. So if you were here last year, we had a display last year that showed what this looks like in a plexiglass version. Again, we've got an inlet up here. There's actually an annular shaped metallic DOC. The flow comes through the DOC. There's a swirl baffle in here that begins to create the swirl. The doser injects down the middle. Again, it doesn't hit the wall. It does a nice job of vaporizing before it hits the SCR face. And this can be used either in SCR alone or with an SCRF, depending on what the application is. Okay, so it can be reasonably conveniently located under a step or under a hood. Down in the bottom right is basically the parametric design that we have. What's the power that you're looking for? Change the diameter of this device, and it can go from small to large or in between. Okay? Next configuration would again be another swirl style mixer. This one, if you break away to the inside, has a DOC and a DPF integrated together. And then here's that swirl twister style mixer again injecting down. Now you've got a nice perpendicular flow compared to where the inlet is. You can put a nice long length between the outlet of the DPF and the SCR face. Plenty of room for mixing. Come up with a nice A-post configuration that doesn't look like it's bolted on. You can actually give some aesthetic view to the tractor. And again, some of the swirl characteristics that you see are up there. So those are kind of the three swirl style arrangements that we have. Again, we're not injecting on a surface at all, but these are all capable to use either in stage 4 or Tier 4 final or Stage 5. So one of the first ones that we'll show a little bit on a wire mesh style spray. So this is one specifically intended for the high dosing rates of Stage 5, and that is the mixer is up here. There's a wire mesh that goes across. We're spraying on the wire mesh. Within there, we've got a mixer that generates a swirl characteristic, so it can be located nicely in a switchover style design. For those that need that level of flexibility, you've got a couple of different configurations, but again, a DOC, a DPF, the mixer in the middle, and the SCR downstream. Multiple different sizes are possible depending on what the power needs are, as well as a couple of different configurations, either an elbow up front integrated into it or a straight section on there. Okay? So again, nicely on a loader. So the last version here that we have is what we call our axial mixer. So it looks remarkably similar to the one that was painted red here a few minutes ago. So it's a completely integrated system with the inlet, the DOC, the DPF, a mixer in a very compact cross section, an SCR system, and the outlet. So the real key to this was finding out how to inject perpendicular to the direction of flow and still have it meet the requirements that we have for uniformity. Different sizes are available, down from the smallest size that can meet up to 150 kilowatts up to 450, 460 kilowatts with a 13-inch size. We do have a display that's actually out here of the 150 kilowatt size. If you want to take a look at it, it's in plexiglass, so you can get a chance to take a look through it. But this can be mounted. One of the beauties of this system is it can be mounted either vertically on a tractor or it can be mounted horizontally on a combine. One of the things that might be a little different about this system is we can work with multiple dosing systems. There is different work that needs to be done, but we work both with Bosch and with the Highlight Cummins style mixer doser to have this system function. So where did this come out? So we generated this system. We call it our axial. How did it do performance-wise? And you can see the configuration that we had it tested in here. We had that 32-point measurement that was downstream of the SCR system. Our uniformity measurements, and these are actual engine test data. So this wasn't like the first time we ran it. This is after quite a while of development. But we were seeing basically our lowest uniformity was at 0.987, all the way up to an upper bound of 0.993. So we were very pleased with this. Early on in the program, we were told you could never dose that close to the SCR face, and right now our data would tend to contradict that. So this is on track for a Stage 5 launch. So in summary, we know that the off-road market has in some case contradictory needs in terms of what it's looking for, but primarily it needs to be small, it needs to perform better than what's out there today. There's a couple of options that Donaldson has that we feel can meet the market needs for Stage 5, a couple of different versions. And what we have done trying to do a little bit better, this isn't intended to be solely a sales pitch, we've actually walked through some of what we've done to try to get to that point because we think that's important things for the industry in terms of understanding that level. So thanks for your attention. Any questions, I'd be more than happy to take those.